All right, so this is the solutions to the second free response question set. In the first one, we have a set of data here about grain being added to a silo. Time 0, the silo is empty. The rate at which the grain is being added is in the table. It's measured in cubic feet per minute from 0 to 8 minutes. We need to select the value of G. Okay, so only certain values of G are there. Using the table, approximate G prime of 3. All right, so G prime of 3 can be approximated by using the average value around 3. So the 2 points that are around 3, or the average, not rate value, but average rate of change. The 2 points that are around 3 in the table are 1 and 5. So we use G of 5 minus G of 1 over 5 minus 1. G of 5 is given as 20.5, and G of 1 is 15.1. 5 minus 1 is 4. This works out to 5.4 over 4, which is 1.35 cubic feet per minute squared, or per minute per minute. So that's part A of the first problem. Let's look at part B. Part B says, when the integral expression that represents, write an integral expression that represents the total amount of grain added to the silo from time 0 to 8. So if G is the rate at which it's added, the total would be 0 to 8 G of t dt. And it says to approximate that using the right Riemann sums. So the first interval from 0 to 1 has a width of 1, and the right side height of that is 15.1. The second interval from 1 to 5 has a width of 4. The height there is 20.5. The third interval is 5 to 6, which is a width of 1, which has a height of 18.3. And the last interval is 6 to 8, which is a width of 2 and has a height of 22.7. So using the right hand, you're going to end up with 160.8, and that's cubic feet. So that's part B. Let's look at part C. Part C gives us a spoilage rate, W here, where W is measured in cubic feet. So use the result from part B to approximate the amount of unspoiled grain that's in the silo at time 8. So the amount of grain that's in the silo is 160.8. That's what we get from part B. We subtract 0 to 8 of W of t dt, because that's going to be the amount of grain that's spoiled from 0 to 8. So the total amount there, when you throw that to the calculator, is 61.748 cubic feet of unspoiled grain. All right, so D asks me, at time 6, is the amount of spoiled grain in the silo increasing or decreasing? Well, the rate that grain is being added to the silo is G of 6 at that point. The rate at which grain is spoiling in the silo is W of 6, right? So in the table, G of 6 is 18.3. W of 6 is 32 times the square root of sine of 6 pi over 70. Was it 74? Yeah, 74. So in the end here, that value comes out as 2.236, which is greater than 0, which means that the amount of unspoiled grain is increasing. All right, so that's problem number 1. Let's look for number 2 here. All right, problem 2, they give us a graph, and then says f is related to that graph by taking 3x and then adding the integral function starting at 0. So the first thing we have to do is find f of 7, right? So f of 7 should be 3 times 7 plus the integral from 0 to 7 of g of t dt. This is 21. So if I go from 0 to 7, I have half of a circle with radius 3. So that's going to be negative 9 halves pi. And the last part here is I have a little rectangle over there with a width of 1 and a height of 3. So this works out to be 21 plus, or not plus, minus 9 pi over 2, right? All right, so it also asks for f prime of 7, right? So the first thing I need is f prime of x. F prime of x here is going to be 3 plus, and then by the fundamental theorem of calculus, g of x. So f prime of 7 will be 3 plus g of 7. G of 7 in this diagram is 3, so this is 3 plus 3, which is 6. All right, so that's part A. Let's look at part B. Part B says find the value of x in the closed interval from -4 to +3, at which f attains its maximum value. Justify your answer. All right, so f prime of x we saw above is g of x. That value, f prime of x, on that interval is always positive. So for all x on -4 to 3, its lowest point of g of x is going to be, I'm sorry, f prime of x is not g of x. F prime of x is 3 plus g of x. There we go. So the lowest value for g of x on that interval is -3, plus 3 is 0. So this thing is always greater than or equal to 0, which means on -4, 3, we are always increasing. If we're always increasing, this means that f has maximum at x equals 3 on -4, 3. So that's part B. Let's look at part C. All right, so part C says first find the limit as x approaches 0 for the negative side of g prime of x. Well, g prime of x is the slope, right, of g as we're approaching from the left. The slope of that line that's approaching from the left is going down 1 over 2. So that's going to be -1/2. It's just the slope of the line as we approach 0 from the left. If I look at the right-hand side, that's a semicircle, which means that thing is going to make a vertical asymptote there. So g prime of x, as I'm coming at it from the right, is undefined, or in terms of the problem, does not exist. All right, so part D of this is going to take us a little bit more room because it's a L'Hopital's rule problem. So let's get a clean screen for that. So part D here says the limit as x approaches -2 of f of x plus 7 over e to the 3x plus 6 minus 1. All right, so note f of -2 is equal to 3 times -2 plus the integral from 0 to 2 of g of t dt. That's going to be -6 minus the integral, this should be -2, from -2 to 0 of g of t dt which is -6, and there's a little triangle there. So that's 1/2 times 2 times 1, which is going to be -6 minus 1, which is -7. So if I work with that limit, I get the limit. Well, that limit, after all said and done here, if I put the -2 in there, I'm going to get -7 plus 7 over e to the 0 minus 1. That comes out as 0 over 0. So that sets me up for L'Hopital's rule. When I apply L'Hopital's rule here, I get the limit as x approaches -2 of f prime of x over 3e to the 3x plus 6, right? So I need f prime of -2 over 3. So this is 3 plus g of -2 over 3, which is 3 plus 1 over 3, which is 4/3. And that's the whole problem. All right, so that's just a straight up L'Hopital's rule problem. Let's move on to number 3. All right, so problem number 3 has a bit of a weirdness in this because of the absolute value. In part A, we're told that g prime of x is equal to 2 times the absolute value of x. So another way of saying that is dy dx is 2 absolute value of x. All right, so this means that like dy is equal to 2 absolute value of x dx. Take the integral there. Y is going to be the integral of 2 absolute value of x dx. All right. So when I'm left of 0, or let's start with right of 0, y is going to equal x squared, because that's just going to be 2x when I am right of 0. When I'm left of 0, this is going to become -2x, so y is going to equal -x squared when x is left of 0. So g of x is x squared negative when x is negative, and it's going to be equal to x squared when x is non-negative. All right, so we also want the double prime. Now, g prime of x is non-differentiable at 0, so we're not going to get a second derivative at 0. If I take the second derivative of x, I'm going to get 2 when x is positive, and the second derivative of x will be -2 when x is negative. So this means that g double prime of x is a composite function where -2 when x is negative and 2 when x is positive does not exist when x is 0. So this one does equal 0 at 0. This one doesn't exist at 0. Okay, so let's look at part B of the problem. Find the x-coordinate where any point of inflection. So if you think about this, g double prime of x is -2 here, does not exist at 0, and then is 2 here. So it changes signs at 0. So the only place g double prime of x changes signs is when x is 0. So there is only one point of inflection at x equals 0. All right, so let's move on to part C. All right, so part C says h of x is the integral function of the square root of 1 plus 4t squared dt. For x greater than 0, h of x is the length of the graph of g from 0 to t. Use Euler's method starting at x0 with 2 steps to approximate the size of h4. Alright, so if h of x is integral 0 to x square root of 1 plus 4t squared dt, this means h prime of x is going to be the square root of 1 plus 4x squared. Alright, so using Euler's method, we're starting at 0, 0, right? Because when x is 0, or t is 0, right? This is what we want. We want the starting point at 0, 0. Because, is that right? Yeah, so x sub 0, because we have the initial value. There it is. The initial value is in this somewhere. Hold on. That's why I know h of 0 is 0, because h of 0 is the integral from 0 to 0 of square root of 1 plus 4t squared dt. Both bounds are 0, which means h of 0 is 0. So my starting point is going to be x0, y0 for Euler's method, right? I'm doing 2 steps to get to 4. So my first step is going to take me to 2. My y moves as 0 plus the step size, which is 2, times the derivative at 0, 0. The derivative is here. It's only dependent upon the x. So this is going to be the square root of 1 plus 0, which is the square root of 1, which is just 1, which means that the first step takes me to 2. So x sub 2 is now going to get me 4, which is where I want to end up. Y sub 2 starts me at 2, plus the step size times the derivative when x is 2. So 2 squared is 4, plus 4 is 16, plus 1 is the square root of 17. So the value is 2 plus 2 radical 17, and that's my answer. We have that h of 4 is approximately 2 plus 2 radical 17. That's it. All right, so let's look at part D. All right, so part D says find the value of pi over 2 to pi of g prime of x cosine x dx. All right, so g prime of x is given above as 2. So this is pi over 2 to pi is given a 2 absolute value of x cosine x dx. But on this interval, x is always positive. So this is pi over 2 to pi of 2x cosine x dx. So this is a by parts problem. So let u equal to x, dv equal to cosine x dx, du dx is 2, which means that du is 2 dx. Take the integral of both sides here, means v is going to be the sine of x. So u times v, that's going to be 2x sine x from pi over 2 to 2 minus the integral of v du, which is going to be 2 sine x dx. Right, so sine of pi is 0. Sine of pi over 2 is 1, so this is going to be just pi out here minus pi over 2 to pi. The antiderivative of sine is the negative cosine, so it's going to be plus 2 cosine x from pi over 2 to pi. So this is negative pi plus 2 times the cosine of pi is negative 1 cosine of pi over 2 is 0. So this is negative 2 minus pi. And that's final answer. All right, so there you have it. A little bit of by parts problem there. All right, so let's look at number 4. You are given a differential equation, dy dt is equal to negative 0.02 y squared. So note, this is in terms of y, not in terms of t. So that's really, really important. We need to know for part A, we want to use the line tangent to f of t at time t equals 0 to approximate where we are when t is equal to 2. All right, so we do have an initial value in this. We know that when t is equal to 0, y is equal to 10, right? So dy dt at time t equals 0 is going to have y being 10, so that's going to be negative 0 minus 0.2 times 10 squared, which is just negative 2. Okay, so that means that the slope of y with respect to t is negative 2. So we want y minus y null is equal to dy dt times t minus t null, right? So y minus 10 is equal to negative 2 t minus 0. So y is equal to negative 2t plus 10 is the tangent line when t is equal to 0. And we want the approximation for when t is equal to 2. So this is going to be negative 2 times 2 plus 10, which is 6 grams. All right, so that's problem 4A. Let's look at part B. Part B gives me this picture with this being the y-axis and this being the t-axis of some sort of like hook here, and asks, can this be the graph that solves this differential equation? Well, here's the thing. dy dt is equal to negative 0.02 times y squared. Since y squared is always positive, this thing is always negative, regardless of what t is. So that means that as I'm going from left to right, as t increases, so does y. Well, that's not the case. Sorry, that's not true. This always has to be less than 0. So as t increases, y decreases. So this part of the curve where y is going up as t is increasing can't exist. So this cannot be the curve. Be a solution to dy dt. All right, so let's look at part C of the problem. All right, so part C of the problem says find an expression y equals f of t by solving this with the initial condition that at t is 0, y is 10, right? So we're actually going to try to solve the differential equation. dy dt is equal to negative 0.02 y squared, right? So this is the same as saying dy dt is negative 2 over 100 y squared. So this means that I am negative 100 over 2 y to the negative 2 dy is equal to dt. A little simplifying here makes this negative 50 y to the negative 2 dy is equal to dt. Take the antiderivative of both sides. This is going to come out as 50 over y. And this is going to come out as t plus some constant. So we know that y is 10 when t is 0. So that implies that c has to be 5. So 50 over y is t plus 5. You could probably stop there, but let's get it as y. Y over 50 has to equal 1 over t plus 5, which means that y is 50 over t plus 5 is the solution to that initial value differential equation problem. So this brings me to part D. Okay, part D of this problem is literally all about reading and decoding. Determine whether the amount of the substance is changing at an increasing or decreasing rate. Explain your reasoning. Now, we already know that the amount of the substance is decreasing over time. How do we know that? Because dy dt is always negative. We want to know if it's decreasing faster or slower. Is the decrease changing at an increasing or decreasing rate? Okay, so what we need to do here is we need the second derivative. That's what it's asking us for. Like, what can I determine about the second derivative here? So the first derivative with respect to t is 0.02y squared. So if I take the second derivative of y with respect to t, I get negative 0.04 y times dy dt. This is implicit differentiation because I'm taking derivative with respect to t here. Okay, so this is negative 0.04 y times negative 0.02 y squared, because that's what dy dt is equal to. All right, so this is now positive 0.0008, right? Y to the third. Well, okay. But we know that that value, because we start at time 0 with a positive y, is always going to be positive, which means that the amount of substance is changing, though it's decreasing, it's changing at an increasing rate. So this thing is both decreasing, but it's decreasing faster as time goes on, because the second derivative is positive, which means that I am decreasing faster as time goes on. All right, so there you have it. That's the whole problem. Sticking to it. We're done.